Welcome back to our next video here for Unit 4. This time we are going to go through 4.2 and 4.3. So let's get right into it. 4.2, it deals with soil formation and erosion and how this is going to help to support the geosphere. So geology, just as a simple definition, is the study of dynamic processes that occur on Earth's surface and in its interior. So the crust, the mantle, the core, those are going to be things that are studied by geologists. Most typically, they're going to be concerned about the crust and maybe the upper mantle. But if we are talking about the geosphere, well, that is the core, the mantle, and the crust. So Earth has been around for billions of years, and primitive Earth has cooled down. So it cooled down over millions of years to where, you know, at least the crust is cool enough where it is solid. There are three zones in the geosphere: the core, mantle, and the crust. The outermost one is the crust. That's the one that we are most familiar with, and that we're really going to be talking about today. But keep in mind that the heat, right, some of it which was lost over this period of millions of years, there's still quite a bit of heat at the center of the Earth. So the core, the mantle, and the crust, we'll talk a little bit about the core and the mantle, and then we're going to continue talking about the crust through the rest of this section. So the core is the innermost zone, so it is the center of the geosphere. It is made out of mostly iron, and it is very hot, so there's quite a bit of energy there in the center of the Earth. The inner core is solid. The outer core is actually molten. Okay. The mantle is probably the thickest part of the geosphere. The inner portion is the asthenosphere, where it is made up of partially melted rock, flows in convection currents. So remember, it's going to be very hot near the core, and the hot molten rock is going to flow up towards the surface, where it will cool down and then flow a little bit off to the side before going back towards the core. That would be a convection cell. The outer portion of the mantle is entirely solid rock, where it will be part of the tectonic plates along with the crust. And then the crust is the outermost layer of solid rock. It is cool. It is not very hot like the mantle or the core are. And the crust contains all the mineral resources that we as humans use. Okay, so a mineral is defined as a naturally occurring chemical element or inorganic compound that exists as a crystalline solid. So we'd be talking about, you know, something like maybe silicon dioxide, like, you know, with quartz. There are many minerals that we utilize, that we get from the geosphere in the crust. So there are three different types of rocks, and so sedimentary, igneous, and metamorphic rocks. A sedimentary rock is a rock that is made up of many sediments, right, that have come together to form the rock. And plant and animal remains can become part of sedimentary rock too. And okay, so it's really just a big conglomerate of all of these sediments together. An igneous rock is formed from magma. So it is magma that is cooled and hardened. And so it started as liquid magma that had then cooled and hardened. Metamorphic rock is existing rock, so it could be your sedimentary or igneous rocks, but it is an existing rock that has been subjected to high temperatures or high pressures, or even chemically active fluids. So it causes the metamorphic rock to change in some way. Okay, so rocks, there's even a rock cycle. And they're recycled over millions of years. So there are a few processes at play. So erosion is the one that we're most familiar with that occurs at the crust surface. Erosion will result in the formation of sedimentary rock. When rock is melted, it can then become igneous rock once it does cool down and harden. And metamorphism is just, remember, the high amounts of heat or pressure or chemical substances that can cause the rock to change in form. So there are a few cycles that are going to be important in the formation of soil. Okay, so what we just talked about was the formation of rock. Soil is kind of going to be the breakdown of rocks. Okay, weathering is probably one of the most important processes here. And this is just where an external force, such as wind, or perhaps the breaking apart by water, or ice wedging, which is when water gets in between pores in a rock and then cools down and freezes and expands and breaks apart the rock in that way. We could be talking about chemical weathering like acid rain, so the reaction of the acid rain with a substance in the rock. Think of something like limestone. Okay, but sediment is going to get transported through runoff, right? By it gets carried off by water. All right, so just over time, rock is going to break down from these various processes, okay, these weathering processes. And as the rock begins to break down, right, a contributor could be certain organisms like lichens that contribute to the breakdown of the rock by releasing chemicals that will cause chemical weathering. All right, but those are going to die. And as the living organisms die, their remains will become part of the soil. So providing a little bit of nutrients there. And eventually we're going to get a mix of the rock, which is heavily broken down now, where we have much tinier sediment, as well as organic matter, the humus. And eventually it's actually going to stratify, where we'll actually have several layers of distinct parts of the soil. All right, still have the bedrock down here, but instead of being completely rock, now a lot of that has broken down to form the soil that we have here. Okay, so primary succession uses this process, right? The weathering processes that will break down the bedrock and start to form the soil. Don't forget that organisms, as they die, their bodies are going to get broken down, and the nutrients that they had in their organic matter are going to become part of the soil. Okay, so organic matter is a very important part of soils. Decomposers and detritivores are going to break down these the dead organic matter, or perhaps waste, or even leaves that have been shed by trees, and that will contribute to the nutrient levels in the soil. And probably the most important part of soil, okay, it's not just the sediment, it's not just all of the nutrients, but air and water also need to be there, because those two things are going to support the growth of plants in soil, excuse me. All right, so this is a process that takes quite a long time. It can be hundreds of years, maybe thousands of years, depending on the amount of like rainfall or wind or something like that. But the minerals and the organic matter are going to build up over time, and humus, which is the partially decomposed organic matter, that is going to accumulate. Again, it is incorporated into the soil, and the organic matter, as it continues getting broken down, will release nutrients in the soil. Okay. So here are the layers here. We have the O layer, which is pretty thin. That's mostly just the organic matter, like leaf litter and stuff like that. The A surface, which has a bunch of the sediment plus a lot of organic matter. B has less organic matter. Minerals might leach down here, meaning that they like will kind of fall, get carried by water down to B. C is the weathered parent material. So it's not the solid rock like we have down here, but it is this rock as it continues getting broken down, okay, before it really is incorporated as part of the soil. So there's gonna be a lot of rock down here in the C layer or horizon. All right, so healthy soils are gonna be ones that can retain water, all right? Water needs to be able to flow through, yes, but water also needs to be retained. So a good mix of the different particles in the soil will help to not just let water flow through, but also will let the water, will help to hold the water there too. So soils retain water, and that water can evaporate and go into the atmosphere. So that can be helpful in some weather conditions. The moisture in the soil helps to dissolve nutrients that plants will only be able to get from the water. So that is another important characteristic of soil and why water is important there. The particle texture is going to affect the water flow and the retention that we were just talking about. So there are really three main categories for the particle texture that we'll be talking about shortly. So the larger particles are more permeable and allow for more porosity or more spaces between them, okay? And another rather important part of soil is that as the water is flowing through, it filters and cleans the water. Okay, so our different size particles here: sand, silt, and clay. So sand is the largest. It is the most permeable, so the largest gaps in between these particles. Silt is in between, much smaller than the sand particles, but also still bigger than the clay, right? So small, less permeability, because as you can see, there's less space in between each of these just because they're smaller. And clay is the least permeable. It is the smallest. And so water will not really be able to flow through here, but an important part of any soil is going to be our clay that would help to retain the water. Okay, we just can't have too much of the clay. There is such thing as having too much of a good thing. All right, so that's going to bring us to our next section, 4.3. So let's get right into it and look at the composition of soil. All right, so think about what are the soil horizons again. So remember the A horizon, the B horizon, and the C horizon. And then at the very top, the O horizon. So think about what those are, what they were composed of, and let's talk about them now. So towards the top, at the top, you'll have O, and then right underneath that is A. So this is where most of the organic matter in soil is going to be found because it is the closest to the top. That's where most plant roots are going to be. That's where the leaf litter and the other decaying organic matter is going to be. So naturally that A is going to be where organic matter is going to be primarily found, but O is going to be where the leaf litter is. So that's going to be on top of our soil. So in fertile soil, we're going to have some organisms that help to decompose and aerate the soil. There will be bacteria that can help to fix nitrogen. So remember, plants can't use N2 from the air. Bacteria helps by converting that nitrogen into usable forms for our plants. And there should also be a lot of humus, which will contain minerals and nutrients that need to be used by plants. Okay, underneath that, we have the subsoil and the parent material, so B and C. This is where most of the inorganic matter of the soil is going to be, because this is where a lot of the rock is either being broken down or minerals are going to be leaching down into this layer from above through water, okay? So subsoil and parent material, they contain the broken down rock particles. So gravel is quite big, sand is smaller, silt is even smaller, and then clay is the smallest yet. Okay, so you can take a look over here at this chart. So sand is the largest particle, right? And there can be several classifications of sand, but even the fine sand is still much bigger than silt and even that much bigger than clay. So even clay is going to be just a small part of the silt. Okay, so the texture of the water, of the of the soil plus the water retention of the soil is going to be dependent on how much clay, how much silt, and how much sand there is in the soil. So remember, the water retention, that's the amount of water that can be held by the soil. Land productivity is heavily dependent on that, because if the soil can hold water, then that's good. If it can't, then that's not going to be very good for primary productivity, where plants need to get their water from the soil. Okay, so the larger particles like the sand have higher soil porosity, but water is not going to get held by it, so it just kind of flows right through. The smaller particles do not have as much porosity, but they will help to retain the water, at least what can get in there. So we need a balance between these larger and smaller particles to help to retain water. All right, get it in the first place and then to retain it too. In addition to that, clay particles typically are negatively charged. They attract cations like calcium or potassium that have positive charge. So having a decent amount of clay will be good and allow soils to be fertile because they have lots of particles, lots of nutrients. Okay, so this is our soil texture triangle, and you're going to need to be able to read this. Okay, so what we are looking at here is the percentage of clay, silt, and sand. So any point on this graph is going to have a certain amount of each of these particles. Okay, so loam is going to have a mixture of all three of these. And that's why loam is typically considered to be the best type of soil, because as you look down here, it's not great at anything, but it's not bad at anything either, right? So it has medium nutrient holding capacity. So the triangle that we have over here, what you are going to want to look at are these numbers here, okay? So for sand, notice how it's going like this. You're going to be looking at the diagonal line that's going up here to the left, right? For the percent clay, you're going to be looking at the line here that is going horizontally. For the percent silt, you're going to be looking, right, going down this way, you're going to be looking at the line that is going diagonally, but down to the left. Okay, so at any point here, if I were to look at this, right here in the center, well, we got 60% clay, 20% silt, and then 20% sand. Okay, and that is all for our section today.